Okay, I just wanted to show you guys how to use the toolbox that's given to us in SolidWorks. With the toolbox, what we can do is we can create gears. I understand that many of the students are asked to create gears for their course project. So although we haven't covered it in the labs, I thought I'd just make a video really quickly to show you guys how you can do that with SolidWorks the easy way. To do that, here I've opened up a new part. If I go navigate to the right of the SolidWorks window, you'll see Design Library. We want to click that. Then I'll have to navigate to Toolbox. So either click here or open up Toolbox at the top. You can work in either ANSI inch or metric or any of these other design standards. In this case, I'm working with the ISO standard. Again, ANSI inch or metric is probably the easiest way to go. But for now, we'll just pick ISO. So in this case, I would like to make a gear, which is under power transmission, then gears. And we'll see we have a couple options. We have spur gears, helical gears, a rack, which is just an elongated spur gear. So in this case, I'm going to go ahead and make a spur gear, which is the easiest type. If I right click on spur gear, I have the option to configure or create part. So if I select create part, what it's going to do is create a new spur gear for me based on parameters that I input through the dialog box. So after clicking create part, we'll see configure component as a dialog box open for us. And if I scroll down here, I can see all the different properties of this gear. So as an example, I've created two test gears, which are just random parameters that I've picked that will work in an assembly. Of course, there's a little bit of machine design know-how that you should know before you start creating a gear, but otherwise, for the most part, from my understanding, your course project doesn't really require that high level of an engineering design aspect to it. So just go ahead and pick whatever works for you. Guess and check is probably the best way to go right now, or if you'd like to learn a little bit about machine design, I'm sure there's videos or information available on the internet that you could look at. Once you select the parameters that you would need for your gear, so the module, number of teeth, and all that, you can go ahead down to file name and specify a file name. So it's going to save this part as a separate file under the copied parts folder under SolidWorks data. You can find that easily once you've created this part. It'll show here. I'll just show you right now. So I've not used this name here. I've used test 2 and test 1 for the two parts that I've created, and I'll show you those right here in my assembly. So for this assembly, I've just created the two gears, one with 30 teeth, one with 15 teeth. All the other parameters are basically identical, and just for an explanation purpose, I'm going to go ahead and model them here in this assembly. So you can see here I have my two parts. Of course, if I right click and click replace components, it's going to show the folder where those parts are saved. So in my case, it's on my hard drive, SolidWorks data copied parts, and it's going to put any of the parts that I used from the create part dialog box under toolbox. It's going to put them there. So by default, that's the save location. Go there, find your parts, open them up in a new assembly, and I just want to show you guys how you can mate the gears so that they'll work together. So if we see here, I have the smaller gear, the larger gear is fixed, and when I rotate my smaller gear, we can see here that it meshes real nice and it makes the correct number of rotations for one rotation of the larger gear. So to do that, we set up a few mates. So first, I set up a distance mate between the center of the large gear and the center of the smaller gear. It's a little bit of an optical illusion, but both of these shaft diameters are identical on these gears, and that was set by the parameters in the SolidWorks toolbox. So I've set here a distance from the center of this gear to the center of this gear, which enables my gear teeth to engage with each other as they rotate, and we don't have any bottoming out of the teeth with each other. So it works like that. As well, I have a coincident mate between the face of the large gear and the face of the smaller gear, so that way they are completely flush on the front and on the back. The last mate that I have to set up is a gear mate. So we can do this by creating a new mate, selecting the shaft cutout in the gear, then selecting the shaft cutout in the second gear. Scroll down to mechanical mates, and under mechanical mates we're going to pick gear. So the gear ratio is going to be initially defined as a diameter, So if you do not have an actual gear like this, if you're just using two blank discs in the place of a gear, then you would just set the diameter of those two large plates. In this case, because I have created actual gears and I know the number of teeth, I would set the ratio of 30 for the large and 15 for the small. So I've already created this mate, so I'm just going to go ahead and delete that one. I don't need it. But in this mate here, the one that is displayed here in the assembly, you can see here I mated the small gear to the large gear with a 15 millimeter to 30 millimeter ratio. The ratio itself is just a number. So you could go 15 teeth to 30 teeth, and it's the same thing as saying 15 millimeters to 30 millimeters. So once you've done that, in this case I just fixed this gear so it doesn't move, and you can see here when I rotate, everything meshes as it should. And that's my way of creating gears in SolidWorks. It's probably the easiest to get started. There are other ways. You could of course create these gears from sketches and just do them manually. However, if you're going to work with a helical gear set or bevel gears, it becomes fairly difficult. So I would suggest go ahead, use the SolidWorks Toolbox. Just make sure that you understand what you're creating and make sure that when you mate your gears that they do work properly, because it would be a real shame for you to take these gears, 3D print them, and then have them not work in your actual design. So go ahead and make sure you do all the design work properly in SolidWorks, and then go ahead and move to 3D printing.